You know how it is in the world of AI. Every so often, a new paper drops that feels like it could change everything overnight. Well, today, we're diving into one of those. It's a revolutionary algorithm called TurboQuant, and it has set the AI world on fire with massive excitement and, yeah, a whole lot of drama.
And the hype really kicked into high gear with claims just like this one. I mean, an 8 times speed up while using 6 times less memory? Look, in the world of large language models, those numbers aren't just an improvement, they are a gigantic leap forward. This is the kind of thing that could totally redefine what's even possible with AI.
But whenever you see claims this big, you have to ask the big question. Is TurboQuant the real deal, or is this just another case of AI enthusiasm getting way ahead of itself? That's what we're here to figure out. We're going to look at the promise, the science, the controversy, and the final reality check from the people who put it to the test. All right, so let's start with that big promise. What's the problem TurboQuant is supposedly solving that has everybody so fired up? Well, it all boils down to this huge bottleneck in how our current AI models work. The problem is something called the key value cache, or KV cache for short. The easiest way to think about it is as the model's short-term memory. So as you give an AI a longer and longer prompt, like say feeding it a huge document to read, this cache just gets bigger and bigger, and it eats up an incredible amount of super expensive high-speed memory. We're talking about needing a staggering 349 gigabytes of VRAM just to run 3 AI agents at the same time. This is the wall that TurboQuant promises to completely demolish. So let's break down the official claims from the Google research paper. They promise to slash that memory footprint by up to 6 times and speed up the key computation by 8 times. And here's the kicker. They claimed it could do all of this with zero loss in accuracy and without any expensive retraining of the model. I mean, it sounded, frankly, almost too good to be true. Which, of course, brings us to the science. How on earth could one algorithm deliver such incredible results? Let's break down the core idea. And you know what? It's actually more intuitive than you might think. At its heart, TurboQuant is a type of vector quantization. Basically, that's just a really clever way of taking complex data, like, say, the meaning of a word, which is represented by a long string of numbers, and shrinking it way, way down into a much smaller, simpler form to save a ton of space. And this is where it gets really cool. The Google team explained the core trick with this fantastic analogy. So instead of describing a location with your standard grid coordinates, like go 3 blocks east, 4 blocks north, TurboQuant basically rotates the data's perspective. It describes it with a distance and an angle, like go 5 blocks total at a 37-degree angle. Just that simple shift in how you look at the data makes it way, way easier to compress efficiently. So the whole thing boils down to this really elegant 2-step process. First, it does that clever rotation to make the data super easy to squeeze down. But that compression always creates a tiny bit of error. So for step 2, it uses this tiny 1-bit error checker on that little bit of leftover mistake. This corrects any inaccuracies and makes sure the final result is still incredibly precise. It's a brilliant solution. But just as the hype was reaching its peak, the story took a sharp and dramatic turn. Another team of researchers stepped forward with some pretty serious accusations, and that kicked off a very public and pretty intense academic dispute. And you can really feel the frustration in this quote. It comes from the authors of a different paper called TurboQuant. They basically said, hey, we tried talking to the TurboQuant team about the similarities in our work and some problems with their experiments, but we feel like we were ignored. It's clear they felt they had to go public. And as you can see from the timeline, this didn't just come out of nowhere. The TurboQuant authors had actually raised these issues privately almost a full year earlier. Even the official conference reviewers spotted the similarities and asked for clarification. So this public statement was really the final step in a long, quiet debate that had been simmering behind the scenes. But maybe the most explosive criticism was about the experiments themselves. The TurboQuant authors pointed out that in the performance benchmarks, TurboQuant was run on a super powerful A100 GPU, a total workhorse for AI. Meanwhile, their own method was tested on a single CPU core. That is literally like racing a Formula One car against a scooter, and then not telling anyone about the difference in vehicles. They argued this made the performance claims look way more dramatic than they actually were. So with all this hype and all this controversy swirling around, the open source community did what it does best. It stepped in to find the ground truth for itself. See, Google hadn't actually released the official code for TurboQuant, so a developer named Omer Hori basically took matters into his own hands. He went through the paper and painstakingly reverse engineered the algorithm, building a public version so that anyone, anywhere, could test the claims for themselves. So, what did he find? Well, first off, the memory savings, they were absolutely real. His tests showed a memory reduction of nearly 6 times on a really popular model, with almost zero drop in quality. So that part of the hype? Totally justified.
But then came the speed up. Remember, the paper claimed an incredible 8x performance boost. And what did the community find when they ran the code? A 1.85x speed up. Now, don't get me wrong, that is still a really solid improvement, but it is a long, long way from the 8x number that was making all the headlines.
And that really brings us to the clear-cut verdict from the community's hard work. The memory compression is a genuine, game-changing breakthrough. No question about it. But that massive 8x speed-up claim, it just couldn't be reproduced out in the real world. So, why did we just walk through this whole saga? Because the story of TurboQuant is about so much more than just a single piece of code. It's actually a perfect snapshot of the entire AI industry right now. So what are the big takeaways from all this? First, that real breakthroughs are definitely happening. The memory savings here are a huge engineering win. But it also shows that hype can be incredibly deceiving. And honestly, this whole messy story is a beautiful example of the scientific process working exactly like it's supposed to. Scrutiny and verification aren't a bug, they're a feature. And it proves, without a doubt, the vital role the open source community plays as the ultimate watchdog. Which leaves us with one final thought to chew on. We are living in the middle of a massive AI gold rush, where there are huge incentives for researchers and companies to make the biggest, boldest claims they can. And in an environment like that, a story like this forces us to ask, who is ultimately responsible for holding all that hype accountable? The answer, it seems, is all of us.